LiDAR is light detection and ranging. Works on a principle of sending a light pulse, rather more precisely a laser pulse ranging from 10 nanoseconds to 40 nanoseconds. Upon reflection from an object, we sense the time taken by the pulse to reach back to our destination. In programmatic point of view, we can say like we shall start a timer when I am transmitting a light pulse and we shall stop the timer when we receive a light pulse. We know the speed of light and time it taken to come back from the timer, and from that how we calculate the distance the object is. LiDAR finds applications in multiple domains. One popular domain is automotive, where your automated cars try to get the data of surroundings through LiDARs effectively. LiDAR is also popularly used in aerial mapping, where a laser keeps on scanning a large area in different directions to get the reflected data, and that reflected data will be analyzed for calculating the yield of crops. And this is a very scientific technique which has been popularly used through LiDAR. One more application is basically a ceilometer. Ceilometer tries to measure how far clouds are, how high the clouds are there, and how thick the clouds are there. The light signal when passed, or a light pulse or a laser pulse, which if transmitted over to a cloud will be reflected back or scattered out. A reflection is different from scattering, where a backscatter is like the light will be dispersed in different directions. The collected light, the scattered light which has been collected at the receiver end, will be analyzed to identify how much is the thickness of the cloud, what kind of cloud is that, and how much height it is. LiDAR is also popularly used in 3D imaging, where you can measure the depth of the object. In regular photographs, you cannot measure the depth of an object, but whereas in LiDAR imaging, if multiple sensors are there, imagine that instead you are having a camera where your each pixel is trying to behave like a LiDAR. Now let's move on to this VL6180X module, which I will call as micro LiDAR. This micro LiDAR, in our lecture, we'll try to use it for small gesture recognition application, as I've shown you in demo. There are two variants of micro LiDAR from ST, which is VL53L0X, VL6180X. VL6180X is the module that we are going to use now. First of all, you have to understand that the module is trying to emit laser, which is harmful to the eyes. This laser is a class 1 laser. Class 1 laser is eye safe. That means you should avoid direct contact to the laser through eye. Any reflections of the laser are safe. If you take a peek into the 6180X module, it looks like this. A closer look. It has a transmitter from which the laser comes out. It has a receiver which tries to collect the laser. These apertures are meant for proper transmission and reception of laser. And there is also an ambient light sensor present on this module. This is also popularly called as time of flight technology. The reason why it is called time of flight technology, as you know, we are trying to find out the time a light ray or a light pulse has taken to come back. When you want to use this particular technology for your needs, it can be of any type. The unique needs can be if you want to measure a millimeter based measurement, as because the light transmitted is of very narrow width, you can actually find out how much precisely the target is located. Whereas in our normal proximity sensing, you may not know like how much far the target is. But in case of in the micro LiDAR modules, you can find out very precisely the measurement. Primarily, when we have started the lecture series, you would have been introduced to this application where a garbage sensor, garbage level detection sensors have been used by municipalities. And also you can use it as a touchscreen button, and you can use it as a ambient light sensor, or even you can use it for door locking applications, and popularly in mobile phones. And even I have came across some out of the box applications like where somebody was trying to use 6180 for detecting whether a person has fallen down or not. When it comes to interfacing 6180 module to Node MCU, we use the I2C bus. As like we have interfaced SSD1306, we interface the 6180X also on the same bus. If you want to use multiple modules, this is the best way for inter-IC communication. Here in my demo, I have interfaced both SSD1306 and also micro LiDAR module on same breadboard over common I2C bus, where I have taken D1 and D2 pins to display first and then to in the same wires to micro LiDAR module, and the power supply is also been shared to both, with which the both will be functioning properly. If you have a look at the demo, when I'm trying to move a target to nearer to the module, it was showing me a gesture as moving. If I'm going away from the module, it was showing me moving away. And you can also see I was able to measure the range very precisely in millimeters. Now let us move to the code.